I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. As some of you might know, I'm providing guidance for the middle school students to understand the concepts in greater details so that they can solve challenging questions. This can help them to compete in any competition like Olympiad and also ensure that their graduation to high school and then to the university is smooth. Join our venture and watch some of these videos which can help you. Thank you. Hi Aryan, how are you doing?
Yeah, I'm doing good. How are you?
Very good, very good. So today what do you want to do?
So in today's class, I think we could maybe start trigonometry, not start, but like dive deeper in trigonometry identities and bearing problems.
Correct. So you're almost at the end of the session. You know quite a few concepts. It's kind of a review time for you, right?
Yeah.
Okay, so you shared some questions on my drive. So let's look into those
Okay.
and select some of them. Did you copy the question correctly?
Yeah, it's the same question. Yeah.
Okay, so let's verify the result. So if I put x as, let us say, 30 degrees, what do you get? So 30 degrees means what? Let's verify the result. Is it okay?
Okay.
Whether it's an identity or not. So tan of 30 degrees will be 1 over square root 3, right?
Yeah.
And sine of 30 degrees will be half. So we get 1 over 2 square root 3. If I do tan x minus sine x, which is 1 over square root 3 minus half, what do I get? I get 2 square root 3 and 2 minus square root 3. Do you see that?
Yeah.
They are not same. They are not same. So therefore, this is not an identity.
Okay.
So
So
because it clearly looked that it's not an identity, so what we can do in such a case, so the question might be, which you copied from anywhere, is whether it is an identity or not. So it's not an identity, and what we have done is we have provided a counter example. You understand?
yeah, yeah,
So if we prove that for some value, both left side and right side are not equal, that means it's not an identity, correct? So taking
yeah,
angle as 30 degrees on both the sides for x, we land up into a different value. And therefore, it is not an identity. So I cannot prove it. Do you understand?
yeah,
So there's something wrong in copying the question, or the question was whether it is an identity or not.
yeah. I think that might have just been the question.
Yeah, that must have been the question. And for that, provide a counter example. You understand the concept of counter example? Just any value which can show that left side is not equal to right hand side. Is that clear to you?
Yeah, yeah,
So it is not true for all the values. It's not an identity. Perfect.
yeah,
So we'll leave it there. So now we'll continue with our questions. Let me erase this. Is this clear to you?
yeah, yeah. It's clear.
Yeah. So where were we? Question number? Okay, we did 6. So we are on question number 7, right?
Yeah.
Okay, can you please help me how we can start with the left hand side? The question is left hand side is what? Left hand side is sine square x times tan square x plus 1. And you know what tan square x plus 1 is, right?
Yeah.
What is it?
It's secant squared x.
And we can write secant square x as 1 over cos, correct? So we
Yeah.
have sine x, and there's no square here, so I'm writing 2 sine x here, right? Do you see that? And secant x as 1 over cos x. Does it make sense?
Yeah, yeah.
So 1 over cos square x rather, right? So tan is sine over cos. So we could rearrange. We could write this as sine x over cos x times 1 over, because we want that cot in the denominator, right? So we'll take
Yeah.
this in the denominator. Cos x over sine x. Does make sense?
Yeah, yeah.
This is like 1 over cot x.
Yeah.
I think the easier method could have been to start with right hand side in this case. Okay. So I'll recommend you to start from right hand side.
So if we did start from the right hand side, how would it how would we go about it? Because like I know it was just like, would we just like simplify the tan x and
Yes.
okay.
So let's do it. Let's do it. No problem. So tan x over cotangent x, right?
Yeah.
So tan is sine x over cos x, and cotangent is cos x over sine x. Is that clear?
Yeah.
Write like this very easily. Is that okay?
Yeah, yeah, yeah.
Yeah. So we already have sine x, sine square x, which we need on the top. And we have 1 over cos square x. 1 over cos square x, which is sine square x times secant square x, correct? And secant square x is 1 plus tan square x. Is that clear to you?
Yeah.
So you could go like this and prove it. So it was either way, not an issue.
Okay.
Did you understand all of that?
Yes. Yeah.
These questions were shared by my student Aryan. I hope you find them interesting and useful. They actually cover the whole topic in a very beautiful way. Thanks to Aryan for sharing all these questions, and I hope many students worldwide will benefit from them. Thanks for your time and all the best.